So this is E1.5, which is quadratic equations in one variable. We're going to go over the 4 different methods that we have to solve quadratic equations. So the first method we have is one that we've already done, which is to solve by factoring. Okay. The second one is to solve using the quadratic formula. Okay, the third method is to solve by using the square root method. Okay, and the last method is to solve by completing the square. Okay, so I'm not going to do too much of the factoring because we already went over that back in E1.1. So I'm just going to do a couple examples of factoring, and then we'll get into the quadratic formula, which hopefully you've seen before, and then we'll go over square root method and completing the square, which may be new to you. Okay, so looking at factoring first, first thing we have to do is have it in standard form, which means everything's on one side so that it's equal to 0. So I'm going to go ahead and move my 22x to the other side by subtracting. So I'm going to subtract 22x from both sides, which gives me x squared minus 22x plus 120 is equal to 0. Okay, I have 3 terms, so I use sum product. When I do my chart, my sum is going to be negative 22. My product is going to be positive 120. So I'm looking for a pair that I can multiply to get 120 that I can combine to get negative 22, which would be 12 and 10. Since I need a negative 22, I need this to be a negative 12 and a negative 10, which still works because when I multiply those together, it gives me the positive 120. And then because my leading coefficient is 1, I can use my shortcut. Remember, my shortcut says that whenever my leading coefficient is 1, the numbers I get in my chart are the numbers in my factored pair. Okay, so when I factor this, this tells me this is going to factor into x minus 12 times x minus 10. Okay, so we've done that part before. Now we just need to go ahead and solve. Once we have factored quantities being multiplied to equal 0, the way that we solve it is by just setting each factor equal to 0. So this means that x minus 12 equals 0 or x minus 10 equals 0. And then I solve each. So I'm going to add 12 to both sides here, which gives me x is 12. And then over here, if I add the 10 over to the other side, I get x equals 10. So this means that my two solutions are x equals 12 and x equals 10. Okay with you entering it like this. In my math lab, it'll have you enter it all in one box, usually with squiggly brackets. So my solution set here would be 10, 12. Okay. All right, let's look at another one. Same idea on this next one. Get it in standard form. Here it already is. It's listed in descending order, so I look for a greatest common factor, which in this case would be 8y. If I factor out an 8y out of the first term, I'm left with y. Factor an 8y out of the second term leaves me with negative 8. Okay, and then I can't go any further because my quantity no longer has a y squared. So I just go ahead and from here set each factor equal to 0 and solve. So this means 8y equals 0 or y minus 8 equals 0. The first one I divide off the 8 to get y isolated, which gives me y is equal to 0. On the second one, I add 8 to both sides, which gives me y is equal to positive 8. Okay, so again, in my math lab, if they ask for it in set notation, we always list the lowest answer or the smallest answer first, which is 0 and then 8. And we put it in squiggly brackets. On an exam, as long as you get the right answers, unless I ask for it in set notation, I'm not going to count off points. As long as you have both your answers circled, I'm okay with that. All right, so let's go ahead and look at the quadratic formula. Hopefully everybody at some point has seen the quadratic formula. If you look on YouTube and search for quadratic formula song, there's some neat little jingles to help you remember it. The quadratic formula will not be given to you on a test. You are responsible for knowing it. Really, it's pretty easy. Okay, the quadratic formula, this is for quadratic equations that look like ax squared plus bx plus c equals 0. In other words, you need to have it in descending order all on one side, and then we're just looking at our coefficients a, b, and c. Once we know what a, b, and c are, we just plug them into this formula and simplify. The reason we need this one is because we can use a quadratic formula to solve any quadratic equation, even if it's one that's not factorable. Okay. So let's go ahead. On this first one, it's all in descending order. So this means that my a is 8, my b is 6, and my c is -1. Okay. And so now I'm just plugging it into my formula. So I get x is equal to -b. My b is 6, so that makes it a -6, plus or minus the square root of b squared. So 6 squared minus 4 times a, which is 8, times c, which is -1. All over 2 times my a, which is 8. Okay, and now I'm just simplifying. I'm going to scroll up so I have more room. So I have x is equal to -6 plus or minus the square root. 6 squared is 36. -4 times 8 is -32, times another -1 makes that a positive 32, all over 2 times 8, which is 16. If I keep going, x is equal to -6 plus or minus the square root of 68, all over 16. Now the square root of 68 is not a perfect square, so I'm going to use reducing radicals to simplify this. Okay, so the square root of 68, that's the same as 2 times 34, and 34 is the same as 2 times 17. So since I have 2 copies of a 2, I can bring that out, and I'll be left with this 17 underneath my radical. I'm going to go ahead and come up here. So now I have x is equal to -6 plus or minus 2 square root of 17 all over 16. And then because every single term is even, they're all divisible by 2. So I'm going to go ahead and factor out a 2, which leaves me with -3 plus or minus the square root of 17 all over 16, so that I can reduce that 2 and that 16. All right. 2 goes into 16 8 times. So my final answer is x is equal to -3 plus or minus the square root of 17 all over 8. If MyMathLab gives you 2 boxes, you just enter them as 2 separate answers, one for the plus and one for the minus. So this would look like x is equal to -3 minus the square root of 17 all over 8, and -3 plus the square root of 17 all over 8. Okay? And I'm going to go ahead and put the little squiggly brackets so it looks like it's in set notation. Okay? All right, let's look at another one, and then I'll show you the square root method. I'm going to go ahead and write the quadratic formula up top so I don't just scroll up and down. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So on this one, the first thing I need to do is get it into standard form. I need my c, or my constant term, on the same side as my other term. So I'm going to add 8 to both sides, which gives me 2x squared plus 6x plus 8 equals 0. Okay. Now, you can see there's a greatest common factor, but since we're solving by quadratic formula, I'm not going to worry about it. I'm going to go ahead and just plug it straight into the formula. So here my a is 2, my b is 6, and my c is 8, which gives me x is equal to -b, again would make my 6 negative, so -6, plus or minus the square root of b squared, so 6 squared, minus 4 times my a, which is 2, times my c, which is 8. All over 2 times my a, which is 2. Okay. Then I want to go ahead and simplify. So I have x is equal to -6 plus or minus the square root. 6 squared is 36. 4 times 2 is 8, times another 8 gives me 64. And since I only have one negative, it's going to be a -64. All over 2 times 2, which gives me 4. All right, so I continue simplifying. The 36 minus the 64 underneath the radical is going to give me a negative number. Remember, anytime we have a negative underneath the radical, that means we're going to end up with a complex number. So I have negative 6 plus or minus the square root. 36 minus 64 gives me negative 28 all over 4. So again, just like before, I'm going to simplify the square root of negative 28. But before I do that, I want to take out the I. Okay. Remember, I is equal to the square root of negative 1. So I have x is equal to negative 6 plus or minus I square root of 28 all over 4. And then over here, I'm just going to go ahead and say 28 is the same thing as 2 times 14. 14 is 2 times 7. So since I have 2 copies of a 2, I can bring that out. The 7 stays underneath the radical. So I have x is equal to negative 6 plus or minus 2i, the 2 that I brought out, the I that I brought out because of the negative, square root of all over 4. And then just like before, all terms are even, so I'm going to factor a 2 off of the top so that I can cancel it with a 4 on the bottom, which is going to leave me with negative 3 plus or minus I root 7 all over 4. Then the 2 and the 4, which will leave me with a 2 in the denominator, which makes my final answer, come back up here so I have more room, x is equal to negative 3 plus or minus I square root of 7 all over 2. Again, on an exam, I'm okay. Well, actually, we probably need to go ahead and break this one apart. Since it has an I, it has a complex number. Remember, with complex numbers, we always write them as a plus bi, which means our term that doesn't have an I plus or minus our term that does have an I. We always keep those separate. So I'm going to go ahead and write this as 2 separate answers. So I have negative 3 halves plus I root 7 over 2, and negative 3 halves minus I root 7 over 2. Okay. I'm going to put the squigglies to show my set notation. Okay. All right, so most of you have seen the quadratic formula before, hopefully. If not, feel free to ask me questions, try some extra problems. I'm going to go ahead and move on and go over the square root method. Square root method basically says that if we have something like a squared equals b, then we can get rid of that square by square rooting both sides, or taking the square root of both sides. Okay, when we do that, we have to do plus or minus. So here, if I were to take the square root of a squared, it would leave me with just an a, because a square root and a square cancel. If I take the square root of b, then I end up with a square root of whatever that number is. So if a squared equals b, then that means a equals plus or minus the square root of b. And the way I get that is just by taking the square root of both sides. So using that method, or that idea here, I have a quantity squared equals 900. So to get rid of that square, what I'm going to do is I'm going to take the square root of both sides. When I take the square root of the left-hand side, the square and the square root will cancel. On the other side, don't forget your plus or minus, and I get the square root of 900. Okay. Now when I cancel my square and my square root, that leaves me with x minus 13 is equal to plus or minus. I want to go ahead and see if I can simplify the square root of 900. Okay, it is a perfect square. 900 is the same as 30 times 30, so this gives me plus or minus 30. And then to solve for x, I need to move my 13 to the other side by adding. So that gives me x is equal to 13 plus or minus 30. Now, because these are like terms, if you leave it like this, it will count you wrong. Being that these are just regular numbers, we can go ahead and simplify and get 2 answers. So I'm going to do x is equal to, and I can do 13 minus 30, and I need to do 13 plus 30. Okay, so if I do 13 minus 30, I'm going to get negative 17. Excuse me. If I do 13 plus 30, I get positive 43. So here my solution set would be negative 17 and positive 43. Okay, and it makes it a little bit easier than having to square out the quantity x minus 13 by doing x minus 13 by x minus 13 and then move the 900 over and then have to factor or use quadratic formula. If you already have a squared item, okay, or a squared quantity, this is usually the easier way to solve it. So let's look at this next one. On this next one, the first thing I want to do is get the thing that's squared, or the base that's being squared by itself. So I'm going to go ahead and divide off this -2. When I divide both sides by -2, I'm left with x plus 10 quantity squared is equal to positive 225. Okay. Then again, just like before, I want to take square root of both sides. When I take the square root of both sides, don't forget your plus or minus on the right-hand side. So this is equal to plus or minus the square root of 225. On the left-hand side, just like before, square and square root cancel. So I get x plus 10. On the other side, the square root of 225 is a perfect square. That's 15. And then I need to solve by getting x isolated, and I do that by subtracting 10 from both sides. So I end up with x is equal to -10 plus or minus 15. Okay. And then I want to go ahead and simplify this. They're like terms, regular numbers, so I'm going to write out my two answers. I have -10 plus 15 and -10 minus 15. -10 plus 15 leaves me with 5. -10 minus 15 gives me -25. So I'm going to write my solution in set notation. So I have -25, positive 5. I leave it like that. Okay. All right. So there's a couple for y'all to practice really quickly. And then I'll go over the answers. Okay. Okay, so I want to go ahead and go over the practice problems. On the first one, we have to factor. When we do some product, we find the pairing -10 and 1, but our leading coefficient is not a 1, which means we have to replace our middle term and do grouping. Okay, once we get it completely factored, we should have x minus 2 times the quantity 5x plus 1, and it's equal to 0 now. Okay, don't forget it's equal. Don't stop when you get done factoring. So we need to set each factor equal to 0 and solve, which should give us a positive 2 and a -1/5. On the next one, it asks us to solve by using the quadratic formula. So again, we figure out what A, B, and C are. Now notice this one was not in standard form. So we have to move that 51 to the other side, which would make it negative. So your C should be -51, not positive. Okay, we plug everything in. When we simplify our quadratic formula underneath our square root, our 1,444 is a perfect square, which then just simplifies to 38. And then we work out both of our answers, which should leave us with -17/7 and +3. Okay. And then the last one asks us to complete it by extracting square roots. First thing we have to do is get the perfect square item all by itself. So we divide off the -3. Don't forget when you take the square root of both sides to put plus or minus on the right-hand side, which gives us plus or minus 3. We move our 7 over, figure out our two answers, which gives us -10 and -4. Okay. I will tell you on a test, if I ask for you to solve by using extracting square roots or factoring or quadratic formula, whichever one I specify, you have to work it using that method. Okay, if you work it using a different method, even if you get the correct answer, I'm going to count it wrong because I'm testing on, do you know the methods I've gone over, not just can you get an answer. Okay, so make sure you're good on each of those methods. Now, the last method we have to go over is completing the square. Okay, which is probably going to be new to most of y'all, unless you've taken a higher math in high school or in college already. Completing the square basically means we want to take something that normally we can't factor or is completing the squares where we take something that maybe normally we couldn't factor, and what we're going to do is create a perfect square trinomial on one side. A perfect square trinomial looks something like x plus, I don't know, we'll say d squared equals c. Okay, this just means that we have something that's a quantity squared. Okay, we want a perfect squared quantity, because if we can end up with something that looks like this, then we can solve it by extracting square roots. Okay, so the whole idea of completing the square is to get our equation in this form so that we can solve it by taking the square root of each side. Okay, now in order to do that, there's several steps. The first step is we want to put it in standard form. Okay, so I'm just going to say write in standard form. Now remember, standard form is descending order. Okay, everything on one side. We're going to write in standard form, then move the constant to the other side. So what we want to end up with in essence is we want ax squared plus bx plus c equals 0, but then we want to move the constant to the other side. Okay, so I would subtract c. Now I'm not going to use a negative because I don't know what c is. So in essence, we want to end up with something that looks like this. Okay, now once we have all the x terms on one side and the constant on the other, then we can go ahead and start the completing the square process. First thing we have to make sure is that our leading coefficient is a 1. Otherwise, it doesn't work. So I'm going to say make the leading coefficient 1 by dividing off any number other than 1. So if your leading coefficient's already 1, you can skip this step. If your leading coefficient is not a 1, you just divide off that coefficient off of every single term. Okay. All right. Then the next thing we're going to do is we're going to go ahead and take the x term or the middle term or the whatever term has just the variable to the first power. Okay, I like to call it the middle term. And what we're going to do is we're going to take half of its coefficient. So I'm going to say take half of the x term coefficient. Then we're going to square it and add it to both sides. Whoops. Add it to both sides. Okay. And what this does is this creates a perfect square trinomial. Okay. All right. So then our fourth step is now we should be able to go ahead and factor one side. Okay. I'm going to say this should leave us with a perfect square trinomial. Okay. So the last thing we do is solve by extracting square roots. Solve by extracting square roots. Okay, so this is our process. I know it sounds like just a lot of but we're going to go ahead and go through it. Okay, looking at this first one, our first step is to write it in standard form, which it's already in standard form. And now we're going to move our constant to the other side. So I'm going to add 6 to both sides. So that gives me x squared plus 4x is equal to 6. Now I make sure my leading coefficient is a 1. Here it is. I don't have anything in front of that x squared. So I want to go ahead and start the completing the square process, which I'm going to do in a different color. I'm going to take half the middle term or half the x term coefficient. So I'm looking at this 4 and I want to take half of it. And I'm going to write it as half times 4 over 1. Because sometimes we'll have to deal with these and they have fractions. And if you start thinking of taking half by multiplying by half rather than dividing by 2, it makes some of these easier. Okay, so I'm taking half the middle term, which half of 4 we all know is 2. Okay, and then I'm going to square it. So I'm going to say square it. So 2 squared. And that's what I'm going to add to both sides. Add to both sides. Now you can leave it as 2 squared or you can simplify it. I'm going to go ahead and just write it out. Some of y'all can do this in their head. That's fine. So I have x squared plus 4x plus the 2 squared that I'm adding to both sides. I'm going to go ahead and write in here plus 2 squared. And I'm going to go ahead and write plus 2 squared over here because I'm going to add it to the other side. Is equal to the 6 that I already had over there plus the 2 squared. Okay. Now I'm going to go ahead and simplify. When I simplify by squaring that 2, I have x squared plus 4x plus 4. And then over here I have 6 plus 4. Notice this piece is a perfect square trinomial. If I wanted to factor this, I need something that multiplies the 4, that combines to 4. That's 2 and 2. So this factors into x plus 2 times x plus 2, or rather, x plus 2 quantity squared. Okay. On the other side, if I combine 6 and 4, I get 10. And now this is something that I can solve by extracting square roots. Okay. So I'm going to go ahead and move this on up over here. So I have x plus 2 squared equals 10. I'm going to take the square root of both sides. Don't forget your plus or minus. So I have x plus 2 is equal to plus or minus the square root of 10, and then move your 2 to the other side by subtracting. Now in this one, since one term has a square root and the other term doesn't have a square root, we're just going to leave it like this. Okay. So if I wanted to write my solution in set notation for this particular example, I would just say x is equal to negative 2, sorry, let me do the minus 1 first, minus square root of 10, and negative 2 plus square root of 10. Okay? And that's as far as we can go. Okay. Now, a couple of things I want to point out, because sometimes they get kind of nasty. There is a shortcut. Whenever you take half the middle term, okay, so whenever I took half the middle term, that gave me 2. Whatever you get when you take half the middle term, that is the number that should end up in your squared quantity. Okay, if this would have been negative 4x, when I take half of negative 4x, I would get negative 2. This would have factored into x minus 2 squared. Okay, whatever that value is when you take half of the x term coefficient, that will be the value always that shows up in your factored quantity. Okay, you do have to go ahead and add it to both sides so that you can see what the right-hand side of the equation is going to equal. But as far as the left-hand side, you don't have to work it out and factor and do all that if you can remember the shortcut. And it comes in really, really helpful when you're doing with fractions, like this next one. So let's try it again. Let's try the same process. So on this one, remember, first thing we want to do is get it into standard form, which here I need to move my 6x to the other side, so I'm going to subtract 6x. So I get 2x squared plus 2x minus 3. And remember, we want our constant term on the other side. So to move that 3 over, I'm just going to add 3 to both sides. So I end up with 2x squared plus 2x equals 3. Now here I do have a leading coefficient that's something other than a 1, so I'm going to go ahead and divide that off of every term. To make that leading coefficient 1, divide every term by 2, so I get x squared plus x equals 3 halves. Okay. Now that I have both my x terms on one side and my leading coefficient is a 1, I can go ahead and start completing the square. So I look at my x term coefficient, which in this case is a 1. So I'm going to take 1/2 of 1, or 1 over 1, which we all know half of 1 is 1/2. Okay. And then remember, we square it and add it to both sides. So I'm going to say square it, which is going to give me 1/2 squared, and I'm going to add it to both sides. So I'm going to go ahead and write that down here, and then I'll write in the rest of my equation. So 1/2 squared, 1/2 squared. So on the left-hand side, I have my original x squared plus x plus the 1/2 squared I got from completing the square is equal to the 3 halves from the right-hand side plus the 1/2 squared that I'm adding in from completing the square. Okay, so if I wanted to go ahead and simplify the left-hand side, this would become x squared plus x plus 1/4, which then we would have to do some product with, which sucks with fractions. So I would need something that multiplies to 1/4 that adds to 1. Remember the shortcut I showed you before? Whenever we took half the middle term, that's what this will factor into. So this actually factors into x plus 1/2 times x plus 1/2, or in other words, x plus 1/2 quantity squared. Okay. On the other side, I need to go ahead and simplify. I have 3 halves plus 1/2 squared is 1/4, and then I need a common denominator. So if I want to write this over 4, I would have to multiply top and bottom, by 2. Let me get a different color, something other than blue. So we know we're doing something other than completing the square at this point. So I'm going to multiply on top and bottom by 2. So this would be 6/4 plus the 1/4 gives me 7/4. Okay, and I'm going to go ahead and rewrite this up here. So I have the quantity x plus 1/2 squared is equal to 7/4, which now I can solve by taking the square root of both sides. So I just want to point out again the shortcut so you don't have to work with fractions. Whatever this value is that you get when you take half the middle term, which in this case is 1/2, that's the value that ends up in our squared quantity. Okay, so you can skip those 4 steps right there if you remember that shortcut. So I'm going to go ahead and take the square root of both sides. So I have the square root of x plus 1/2 quantity squared is equal to plus or minus the square root of 7/4. On the left-hand side, the square and the square root cancel. So I have x plus 1/2 is equal to plus or minus. Now I'm going to go ahead and leave the top as the square root of 7. But since the bottom of the fraction is a perfect square, I'm going to go ahead and simplify that to 2. Okay? And then move your 1/2 to the other side by subtracting. So I end up with x is equal to negative 1/2 plus or minus the square root of 7 over 2. In my math lab, I would go ahead and separate this into set notation, which means I have negative 1/2 minus the square root of 7 over 2 and negative 1/2 plus the square root of 7 over 2. Okay? All right. Let me try one more, and then I'll have y'all try one. Okay. So this one again, I need to move it. Oh, actually, I want to start it in standard form, which means everything's on one side, and then I would move my constant to the other side. Notice here my constant's already been moved to the other side, so it's already looking the way I want it to. So I can go straight into completing the square, which the first thing I look for is to make sure that my leading coefficient is a 1, which here it's a 9. So I need to divide that 9 off. So I'll get x squared plus 1/3 x is equal to 2/9. Now that my leading coefficient is a 1, I can start completing the square, which I do by taking half of the x term coefficient. So half of 1/3 is 1/6, and then remember we square it. So I get 1/6 squared, and I add that to both sides. So I'm going to go ahead and go down here and do 1/6 squared, 1/6 squared. And I'm going to write in the rest of my equation. So on the left, I have x squared plus 1/3 x plus the 1/6 squared equals the 2/9 plus the 1/6 squared. Now, instead of writing this all out on the left because it's ugly, it has fractions, I'm going to use my little shortcut. Remember, whatever I get when I take half the middle term or half the x term coefficient, which here is 1/6, that's what's going to show up in my factored quantity. So this side I know is going to factor into x plus 1/6 quantity squared. Okay. Now on the right hand side I have to do a little bit of manipulating to get these into 2 values that I can combine. So I have 2/9. 1/6 squared is 1/36, and then I need a common denominator, which here would be 36. My second term already has it. My first term, in order to get 9 to 36, I would need to multiply on top and bottom by 4. So 4 times 2 would give me 8/36. Now I can combine these 2 fractions, which means I have x plus 1/6 quantity squared is equal to 9/36. And then I'm going to go ahead and move up here so I have some more room. X plus 1/6 squared is equal to, and I'm going to go ahead and reduce. If you don't reduce here, you can do it later, but it saves us a step. So 9 goes into 36 4 times. That reduces to 1/4. And I take the square root of both sides. X plus 1/6 squared is equal to plus or minus the square root of 1/4, which gives me x plus 1/6 is equal to plus or minus 1/2. And then I move my 1/6 to the other side by subtracting, which gives me x is equal to negative 1/6 plus or minus 1/2. Now these are regular numbers. I don't have square roots or anything left over, so I'm going to get a common denominator and actually figure out what these 2 answers are. My common denominator in this case would be 6. So to write a half with a denominator of 6, I would multiply on top and bottom by 3, which gives me 3/6. Okay. So if I do negative 1/6 plus 3/6, that leaves me with 2/6, and negative 1/6 minus 3/6 gives me negative 4/6. And then I just reduce. So that gives me x is equal to, I'm going to do the negative one first so I can write them in order. Negative 4/6 reduces to negative 2/3, and 2 reduces to positive 1/3. Okay. And we can just leave it like that. So there's one here for y'all to try, and then I'll come back and work it out. All right, so on this example, it's already in the form we wanted in. It was in standard form, and then the constant was moved to the other side. So we can go straight into completing the square. We take half the middle term coefficient, which in this case is negative. So when I take half of -2, that gives me -1, which would allow you to skip all the way down to the bottom here where I highlighted if you use the shortcut. So we know this side should factor into x minus 1 quantity squared. On the other side, though, we need to go ahead and square the -1 so that we can add it to that side as well. So 6 plus the -1 squared is 6 plus regular 1, which gives me 7. Then we extract square roots, which gives me plus or minus the square root of 7 on the right-hand side, and then we just move our 1 to the other side. Since 1 and square root of 7 are not like terms, we can just leave it like this. Okay? We're going to look at a couple of application problems of these types. More often than not, the quadratic formula is the easiest of all these methods to solve. Like I said on a test, if I ask you to use completing the square or extracting square roots, I'm testing you on those methods. So even if it's easier to use a different method, make sure you solve it using the method I ask. Now on word problems, quadratic formula is by far the easiest. I'm fine on you using whatever method you think is the easiest when you're doing application problems. So let's go ahead and look at one. This first one says, a rock is thrown upward with a velocity of 20 meters per second from the top of a 24-meter high cliff, and it misses the cliff on the way back down. When will the rock be 7 meters from ground level? Round your answer to the nearest tenth. Okay, anytime we have these, we use the gravity formula, which is given here. I'll give the gravity formula to you on a test. I won't ask you to memorize it. The only difference is here is whether it's in meters per second squared or feet per second squared, we have a different number value on our coefficient here. So notice it says where g is equal to 32 feet per second if we're dealing with feet, or 9.8 meters per second squared if we're dealing with meters. So in this case, since we see the word meters in our problem, we're going to want to use this one. So I'm going to go ahead and just rewrite this problem using the meters value. So our gravity formula is that our height is equal to -1/2 g, which since we're using meters is 9.8, t squared plus v naught t plus h naught. So we need to go ahead and fill in these. V naught is our velocity, h naught is our beginning height. Okay, so let's see if we can find those things in our problem. It says a rock is thrown upward with a velocity of 20 meters. Okay, so here we go. We see the word velocity. That tells us that our V naught is 20. Okay, from the top of a 24-meter high cliff. So that's where we're throwing it from. So that means that is our initial height, or our h naught. So h naught is equal to 24. Okay. It misses the cliff on the way back down. When will the rock be 7 meters from ground level? So to help, I'm just going to draw a little picture. Let's pretend, I don't know, here's our cliff. And here's our little dude. And he throws this rock, okay? And wherever he threw it from, we know our initial throw point was at 24 feet, okay? And he throws it, and it doesn't hit the thing, and it comes back down, and we're hoping to figure out when the point is that the rock is going to be 7 meters from the ground, okay? So from here down is 7 meters. Excuse me. So we're not looking for when does it hit the ground, which would be easy because we know its height when it hits the ground is 0. We want to know when is its height going to be 7 meters from the ground. So his ending height is going to be 7. So we're going to go ahead and put 7 in for our h because that's our height that we want, is equal to, and I'm going to go ahead and multiply these together. Half of 9.8 gives me negative 4.9 t squared, plus our v naught, our velocity, which we know from our problem was 20 t, plus our h naught, which was our beginning height, which was 24. Okay, so here this is just a regular quadratic equation. Because there's decimals and bigger numbers, we're going to use a quadratic formula. In order to use a quadratic formula, everything needs to be in standard form. So I'm going to subtract this 7 to the other side. So I have 0 is equal to negative 4.9 t squared plus 20t plus 17. Okay, so this means that my A is negative 4.9, my B is 20, and my C is 17. So I'm going to go ahead and plug it into our quadratic formula. Our quadratic formula says that x is, or actually t in this case, because we're solving for time, so t is equal to negative b, my b is 20, so negative 20 plus or minus the square root of b squared, so 20 squared, minus 4 times a, which is negative 4.9, times my c, which is 17, all over 2 times my a, which is negative 4.9. Now, we all know how to simplify this. We did several of these earlier, so I'm going to skip a few steps in my simplifying process. So I'm going to go ahead and say that this is negative 20 plus or minus. Underneath our radical, we should end up with 733.2. And underneath, when I do 2 times negative 4.9, that gives me negative 9.8. Okay. So I'm going to go ahead and continue to simplify. Excuse me. The square root of 733.2 is 27.07767. Okay, I'm going to keep about 5 decimal places. Should give me a pretty accurate answer. All over negative 9.8. Now, because I'm using the quadratic formula, I'm going to get two values, and I have to figure out which one's going to work. So if I work these out, excuse me, I'm going to get t is equal to, I'm going to do negative 20 minus 27.07767 all over negative 9.8. Or my other answer, which would be negative 20 plus 27.07767 all over negative 9.8. Now, when I simplify these two, notice the first one I have a negative minus a negative, which is going to give me another negative divided by the negative on bottom. That's actually going to give me a positive answer. And the answer that I get is about 4.8. Now, in the next one, when I do negative 20 plus 27 point whatever, I'm going to end up with a positive 7 and some decimals. When I divide that by negative 9.8, that's going to give me a negative, which I already know is not a good answer because I'm dealing with time. It actually comes out to about negative 0.7. Okay, since we're dealing with time, we don't want to end up with a negative answer. We can't have negative time. I'm going to write that here. Can't have negative time. Okay. So let's go ahead and we're going to go ahead and just say that our answer has to be 4.8, which in terms of this problem, remember, we're solving for how many seconds is it going to take for this rock to be 7 meters from the ground. So it's going to take 4.8 seconds. Okay, let's look at another one. This next one says, Luke, an experienced bungee jumper, leaps from a tall bridge and falls towards the river below. The bridge is 170 feet above the water, and Luke's bungee cord is 110 feet long, unstretched. When will Luke's cord begin to stretch? Round your answer to the nearest tenth. So let's go ahead and just draw a little picture first. Let's pretend this is the, ooh, that's not straight. Let's draw a better picture. Let's just say this is the bridge. Okay. All right, and then we got some water below. Okay, so here's our water. Now, his cord's going to come all the way down and keep going. I don't know how far it's going to stretch. What we know is that the bridge is 170 feet above the water. So that means the bridge is up here at 170. Okay. We also know that his chord is 110 feet long, right? And then it starts stretching. So once we come down here and he hits this point where he hits 110 feet, after that it's going to start stretching. So we want to know at what height is that. So we're going to kind of work this one backwards. We know if we went all the way up to the bridge, it'd give us 170. Okay, if we come down 110 feet, that's when the point at which his chord is going to start stretching. So to find this distance from the water until his chord starts stretching, I can just subtract the two values. Okay, so 170 minus 110 leaves me with 60 feet. So his chord is going to start stretching at 60 feet above the water. So I want to know at what time is that going to happen. So again, I'm going to use, excuse me, my gravity formula from before. I'm going to go ahead and write it down here. I have H is equal to negative 1/2 times my G, which if you reference above, since we're using feet, my G this time is 32. Okay, plus V naught T plus H naught. Now remember, V naught is my velocity, H naught is my initial height. So I need to go ahead and fill in what I know. My velocity, in this case, if I'm looking at it, I'm seeing, is he being shot up in the air? Is he being shot down? Like at what rate is he falling off this bridge, right? If you've ever watched a bungee jumper, they don't get thrown off, they don't get shoved off, they just kind of fall. So if he's just stepping nicely off the bridge, there's really not a velocity, which means his velocity is 0. So I'm going to go ahead and put over here V naught is equal to 0 because he's just stepping off. Okay, so I know that's 0, so I can plug that in a minute. The other thing I need to know is what is the initial height. Okay, the starting height is he's starting on the bridge, right? And he's just going to step off. He's not being shot up to the bridge and then he's going to come back down on the other side or anything like that. He's starting at the bridge, which means his initial height is 170 feet. So I'm going to go ahead and plug that in. And I want to know his ending height. I'm going to go ahead and write that over here too. His ending height is going to be the 60 feet because we want to know the height above the water, remember, at which point his chord starts stretching. So the time of the height that I'm looking for is his 60 foot above the water time. His initial height is the 170 foot because he's up on the bridge, and his velocity is 0 because he's just, falling off, not being thrown off. So let's plug all that in. So my ending height is 60. I'm going to go ahead and simplify this. Negative 1/2 times 32 gives me negative 16. Whoops, and I forgot my t squared. T squared plus 0t plus 170. Now 0t, since there's 0, that's just 0. So I'm going to go ahead and rewrite this as 60 is equal to negative 16t squared plus 170. Now, I want to go ahead and get this equal to 0. To get this equal to 0, I'm going to move my 60 to the other side by subtracting, which gives me 0 is equal to negative 16t squared plus 110. Now, if you look at this, there's something particular to notice. I don't have a t term. If I don't have a t term, it makes it a little bit harder to factor. It makes it a little bit harder to do quadratic formula because I don't have a t value. But what I do have is a variable being squared. So the easiest way to solve this one would be to just isolate that t squared, and then I can use square roots, extracting square roots to solve. So I'm going to go ahead and actually move my 16t squared back to the other side. So I'm going to add 16t squared. Okay, if you did want to use the quadratic formula or something of that sort, you'll still get the same answer. 16t squared is equal to 110. So I'm going to go ahead and divide off my 16, because remember, before we take the square root, we want the thing being squared to be completely isolated. If I do 110 divided by 16, I end up with negative, sorry, not negative. I end up with 6.0 2.875. Okay, and now I can go ahead and just take the square root of both sides. If I take the square root of t squared, I have to do plus or minus the square root of 6.875, which tells me that t is equal to plus or minus 2.6. Now again, we're solving for t, which is time. So remember, time can't be negative. So I'm going to go ahead and just throw out that negative answer. Time cannot be negative. Okay, which means that my answer here is 2.6 seconds. Which means in terms of my problem, it's going to take Luke 2.6 seconds before his bungee cord reaches its maximum length and then begins to stretch. Okay. All right. So there's one on the next page for y'all to try. I'll give you a few minutes to work on that, and then I'll show the answer. Okay. All right, so this problem says Robert stands on the topmost tier of seats in a baseball stadium and throws a ball onto the field with a vertical upward velocity of 60 feet per second. The ball 50 feet above the ground at the moment he releases the ball. When does the ball land? Okay, so we know our velocity is 60, our initial height, or our h naught, is 50, and since we're asking when the ball is going to land, we're asking when is it going to go down and hit the ground. So we know its height at that point is 0. So we're basically plugging in v naught equals 60, h naught equals 50, and h equals 0. Once we know that, we plug it all into our formula. I use 32 for g since we're dealing with feet, and then we just simplify. I use the quadratic formula. If you factored, you probably didn't do a very good job at it. If you use completing the square, that's fine too. Okay, so once we simplify and I get down to my two answers, since there's a plus or minus, one of your answers should have been 4.5 rounded to the nearest tenth. The other one would have been negative 0.7. We're solving for the time in which the ball hits the ground, so we can't have the negative answer, which means we keep the 4.5, which means it takes 4.5 seconds for the ball to reach the ground from the time that he throws it. Okay. So that is the end of E1.5. So you should now be able to do your MyMathLab assignment for this section, which is quadratic equations in one variable. Let me know if you'll have any questions.